Hey, what's up, everybody? It's Eric Parady, working on the Pre-Calc project. For my objective, I was required to explain when you're given a set of data, calculate the amplitude, the period, the phase shift, and the vertical shift for a graph, or like for like a sine or cosine or tangent function. So basically, when we were doing this, it was mostly along the lines of calculating stuff for like average temperatures, heartbeats, and other world situations. And for me, I thought it was really cool how you could find sine and cosine waves out of these real world things that we see all the time in like doctors' offices and like with stuff on the Weather Channel and everything. So I thought that was really interesting. But the reason I chose this topic was at some points during the test or even during the homework, I thought it was really hard to remember that, for example, the amplitude was always a positive, or calculating the period and the difference between the period of sine or cosine with tangent, and also that the phase shift is represented as a negative in the parent function. And basically I wanted to just solve all these problems that I had with you guys, so when you do all these problems you don't have the problem I have. So we'll start off with sine and cosine, where the parent functions are seen right there in the middle of the screen. Sine equals y is okay. Sine equals y equals a plus b sine, in parentheses, k times t minus c. And the same thing with cosine, except cosine is replaced with sine. So here is a table representing the amplitude, the phase shift, the period, and the vertical shift. We'll start with the amplitude, where is represented in B in the equation. Normally you see it right before sine and cosine in the equation. Always remember that the amplitude is a positive number. It can never be negative. If it is negative, all you would have to do is take the absolute value of the number you get to make it positive. And just the key things to remember about amplitude is that if B is greater than 0, so therefore if the amplitude is greater than 0, then the entire calculated graph is stretched vertically, meaning the whole thing is stretched up and down, wider. But on the opposite side, if B is less than 0, then it is... Oh, wait, I messed it up. Sorry, or no, I didn't. Okay, sorry. Anyways, if B is less than 0, then the graph is stretched horizontally along the x-axis. So therefore, as you move along reading the graph, it is shrunking or is stretched horizontally instead of vertically up and down. For the phase shift, it is represented as c in the equation. This is the shift along the horizontal axis of the graph. So if c is positive, then the graph is shifted that many units to the right. And if c is negative, then the graph is shifted that many units to the left. This kind of threw me off because if you guys remember in absolute value problems or even in parabola problems, say you had 2 times x minus 5. Well, for when x minus 5, that would move on the graph 5 right spaces. Instead of here, if it is negative, you replace it by going 5 left spaces. This is because if you go back to the sine and cosine parent functions, you can see multiplied by k is t minus c. This represents where in the parent function c is negative. So if c is already negative with a given number, so say it would be x minus, say, 4, it will move left 4 spaces. If it's positive 5, then you would switch the negative sign with the positive sign and have it be x plus 5. For the period of the graph shows the range of x values between two consecutive relative maxes and mins. As you know, in a sine wave you will receive maximums and minimums, and this is represented through the frequency because it repeats over time. It stretches in strings depending on the value of k. If k is greater than 1, then the graph shrinks horizontally. If k is less than 1, then the graph stretches vertically. You have k over 360 because this represents the period of sine in the unit circle from 0 to 360. Same thing with cosine. So if you're in degree mode, which I think you guys recall doing, the period is represented as 360 over k. But on the other hand, if you are in radian mode, you can replace 360 with 2 pi, so the period is represented as 2 pi over k. Lastly, we have the vertical shift, which is represented, gotta fix that. Is represented as a in the equation. Really, you can see it at the start, like I drew here, y equals a plus b, or you can see a over here. Hopefully, like that makes sense. It could be plus or minus. The result of this, again, just moves the entire graph up or down. So say a is a positive number, the whole calculated graph that you get moves up vertically on the xy plane. But if a is a negative number, then the entire graph shifts down that many so odd points that you have. Basically, if you have any questions or want more detail about any of the variables that I described, this website right here that I have for you guys just really sums up everything I just said, and it gets like a little bit more in detail and uses a lot bigger math words to describe everything. So again, if you need help, then or come to me or just look at this website to help you describe what's going on. For some example problems, I just thought of some easy things to help you guys out before you do the challenge problem I'll have for you. One of them is write the equation for the sine function of each amplitude, period, and phase shift. And I just come up with an example where the amplitude is equal to 5, period is equal to 360, and the phase shift is equal to 60 degrees. So for this one, you would start out with y equals, so we'll go right here, y equals, so if the amplitude is 5, obviously that is represented as b, so we'll put that right here in the beginning, 5. Since it asks for a sine function, we'll have sine right here. I'll space it out for you guys. Sine right there. Next comes in the period. Since it is 360, it's just a plain flat out sine function, no change in the period whatsoever, so that can be left alone. Next we have the phase shift, which it asks for. So in relation to that, we'll have x for the angle it requires, and that is minus 60. Oh no, it'd be plus 60, my bad. So that's the equation for that example problem. Y equals 5 sine, and in parentheses, x plus 60. Kind of straightforward, nothing too fancy, nothing too hard. Straight up, easy stuff, if you might say. For the next one, we have, or I have written out for you guys, state the amplitude, period, and phase shift of each function. So this time I gave you the functions, and you'd have to state the amplitude, the period, and the phase shift for me in each example problem. We have with us 2 cosine of x. For the computer, I didn't really know how to put theta in, which is the big circle with the line through it, but that just x represents the degree. Don't freak out too much about that. So for this one, we have y equals, and then we have 2. If you recall, this is the spot I told you where amplitude would come in. So we have amplitude, oops, all in caps, amplitude equaling 2. For the period, it's like, again, it's self-explanatory. for cosine, it could be out of 0, or it could be 0 through 360. So basically all we have is the period equaling 360 since nothing is over k. So the period will equal 360. Last, we have the phase shift, which is represented right after theta. In this case, is x. And here we don't have any phase shift at all. So basically, when you don't have a phase shift, just leave it as 0 degrees. And that's that. For the next one, we have y equals 6 cosine, and in parentheses, 180 degrees minus x, or theta in this case. For this one, we will start again from the beginning with y equals, and then negative 6, sorry. With this, Alright, my bad, guys. I forgot that negative 6, it looks really weird for that being there, but all in all, no matter what, like I said, amplitude is always positive. So in this case, the amplitude will equal 6. Kind of threw me off as well. That's why I said I struggled with this. So hopefully, even though I'm trying to help you out as best I can while reviewing for myself. So next, we have the period, which in this case, there is no represented period. Mostly you'll find, for example, we'll have, see if you, in 10, tan 4, that 4 is the period. So in this one, we don't have one. But since the negative 6 was negative, the period would have to be negative 360. But normally, when you see a period, I'll explain this in the next problem, but you will see a number right here, for example, 5 or 7 or something. You will see something before this part within the parentheses, which I will explain in the next problem. Next, we have the phase shift, which will equal 180, because it is 180 minus x. Kind of self-explanatory. From there, again, it is what it is. And lastly, we have 10 tan 4 of x, or theta. So again, just state the amplitude, the period, and the phase shift. 10, obviously here, is the amplitude. Again, same thing I've been explaining for you guys before. Nothing new, nothing strange about that. Next, we have the period. Now, for the last two, it's been either 360 or negative 360. But remember, for tangent, it only goes from 0 to 180 for a standard period. That's why I said, remember the period of tangent is out of 180. So for this one, we would have period of 180 divided by 4. Because 4 represented here is k. So technically, the period of it really is 180 over 4, which equals 45. But you represent it as 4 to have it be standard as k. Lastly, we don't really have a phase shift in this one. It's just theta by itself. So we have phase shift equals 0 degrees. Hopefully this was helpful for you guys. Hopefully, if you need me for anything, come talk to me. Review problems in the book, on that website I gave you, or look at the chart I have on this wiki page. Hopefully you guys have been doing good on your projects. I know this was fun. Thank you, Mr. Matesser, for everything you helped us learn this year. And I'll have our example problem for all of you shortly. Thank you.